Hello everyone. In this video we are going to discuss about electrical vehicle project. Based on that project, how to generate live editor, Matlab live editor file, and also this model represent a full electric vehicle model with a motor generator and battery and direct drive transmission and associated powertrain control algorithms. Also, you can use this model for powertrain matching analysis and component selections control and the diagnostic algorithm design and hardware in the loop, that is HAL testing. One separate video is posted in my channel, that is hardware in what is meant by hardware in the loop testing, particularly for this electric vehicle. Okay, in this model we can able to analyze the power, electric vehicle power and energy. To generate energy response, here double click this block to analyze power and energy to open a live script. Then we can run this model. This one, once you double click on that power and energy block, here you will get this Matlab live script block. Run this script to evaluate and report, to get the report power and energy consumption at the component and the system level. Also we can use this result to analyze energy and power losses at the component and the systems level. Now you can see the each and every blocks here. Here is the drive cycle source block. To measure fuel economy and emissions of vehicles typically run on a drive cycle, meaning a predefined trajectory of vehicle speed over time. Here in this block generates a standard user specified longitudinal drive cycles. Also this block output is the longitudinal speed. We can import drive cycles from predefined sources and workspace variables including arrays and the time series objects. It is also the drive cycles are available in different kind of formats. Here this drive cycle in the support package can be imported in the drive cycle block of powertrain block set. This powertrain block set is allowing it to easily access over 20 drive cycles that are commonly used throughout the different regions of world, including this one US06 and SC3, HWFET, NEDC, Japanese 10 to 15 mode, and many others. Here, to get this block parameter, have to install the additional drive cycle support packages in drive cycle source. Here for that you need to click add-ons, get add-ons to install powertrain block set. And if you click here means you will get my MathWorks website. For that you need to register MathWorks website, then only will get this add-on. To install powertrain block set cycle data, here the one model will come. Here it is a standard collection. Here now not available here, so that if you are proper net connection and authorized MathWorks user, you can install this one. Here this is a drive cycle source, is a collection of standard drive cycles. It plots the drive cycle source vehicle speed versus time. Here vehicle speed versus time is particularly for this drive cycle source, that is FTP 75 velocity. So based on that you can check US06. Once you select drive cycle source, it's automatically here it is applied here. Also you can plot the US06 velocity plot, and similarly you can use SWFET plot drive cycle highway fuel economy driving schedule velocity. Okay, based on that you can measure fuel economy and emissions and vehicles are typically run on this drive cycle. Here for this understanding purpose we are use NYCC plot drive cycle. Here New York City cycles. Here there are 20 kind of drive cycle models are here. Otherwise you can use your XLS file, that is in form of mat file. We can import this drive cycle source also by using text file or XLS file or XLSX file or .mat file. Based on that you can apply. For this purpose I am using this NEDC plots for the simulation. For this type of simulation I am using New European drive cycle velocity. Then also you can plot this one. We are also applied some more output velocity values and output sample periods. I leave it as default one. Also after giving this one, we have to select this update simulation time block. Then click apply here, then click OK. Here this drive cycle box again used to generate a standard or user specified drive cycle velocity versus time profile. This block output is selected or specified vehicle longitudinal speed here. Here one more block is represented here, environment subsystem. This subsystem creates environmental variable including road grade, wind velocity and atmospheric temperature and pressure here. Then this is a longitudinal drive subsystem. Here this subsystem used to generate normalized acceleration and braking commands. To implement this, a driver model that is used to measure model that used to vehicle target. This uses the vehicle target and reference velocities. This open loop variant allows you to configure the acceleration and deceleration, gear and clutch commands with constant or signal based inputs here. Here also this parametrical in longitudinal speed tracking controller for generating normalized acceleration and braking commands based on reference and feedback of velocities. Then you can set the parameters, the predictive or scheduled or PI. Here some more controls blocks are there, control blocks. I will leave it as the default values. If you want to, you can add your own models, so that you can analyze this maybe easily. Then next block, so open loop blocks also you can use. This subsystem is provided to disable and the driver subsystem expose the driver interface. By using this interface, you can connect dashboard UI blocks or third-party hardware and provides application specified pre-programmed event or time-based signals, or be driven by recorded operator signals for tuning and troubleshooting and model verifications here. And the next one is the controller subsystem, is important one. And in this subsystems, there are powertrain control input and powertrain control output is there. In this powertrain control model, there is a PCM model implements a powertrain control with the regenerative braking control, motor torque arbitration and the power management. Here the regenerative braking control and the battery management systems and the motor torque arbitration and power management blocks is there. Here by using this one regenerative block, this is a series regenerative braking and parallel regenerative block is there. And then this is a motor torque arbitration and power management block. In this block we are discuss about the battery management. These are power management algorithms implemented here. In this power management algorithms, what kind of applications are there to estimate electrical power based on the mechanical power using efficiency map. So check if electrical power is within battery power limits. Also if power within limit, use motor torque command. These are the possibilities are there in this algorithm, predefined algorithms, that is where power management algorithm and the regenerative braking control and brake pedal to total brake pressure request, all the things are implemented here. These are motor control input block. Finally we will get the motor control output block here, torque and motor torque and braking commands. And this is a passenger car subsystem. This is a electrical car subsystems. This here it includes electric plan input and electric plan output and electric plant unit and also the drivetrain unit. And this systems implements a passenger car that contains this two electrical plant and electrical train subsystems. Here this is the electrical subsystem blocks having battery and motor coupling dynamics and battery discharge dynamics. And this one the drivetrain block. In this drivetrain block, if you click here means you can configure your own drivetrain configuration. Here in this mode front wheel drive model is there. Once you click on that, you can select the model to configure the drivetrain models, front wheel drive or rear wheel drive or all wheel drive. You can choose here. For this model I am selecting this active mode as drivetrain mode as front wheel mode. Here these are the blocks are used to get this vehicle output interface. Here this is our vehicle output interface there. Velocity of 3 degree of freedom longitudinal model we are using here. Here this block, that is where vehicle body 3 degree of freedom longitudinal blocks implements 2 axle vehicle body model to calculate longitudinal, vertical and pitch motions. Also this block accounts for body mass, aerodynamic drag and road incline and weight distribution between the axes due to acceleration and road profile. And also these blocks couples the vehicle to tires with a table push stiffness and damping parameters. Here also you can use this interaction type, axle displacement velocity or grade angle or external suspension. And also you can utilize these vehicle parameters, number of vehicles on front axle and number of wheels on rear axles. Based on that you can specify the parameters, that is the longitudinal parameters or vertical parameters and pitch parameters and the suspension parameters and environmental parameters. All things you can specify your own data for analysis of power and fuel economy and emission analysis. All things it can possible by using this model. And then finally this visualization systems displays vehicle level performance and battery state of charge. You can see there is a performance and fuel economy scope here. This block displays vehicle level performance, battery state of charge, that is SOC, and equivalent fuel economy. Result that this result is useful for powertrain matching and component selection algorithms. After you run this simulation, the live script provides the energy summary report. Also it gives the overall summary. This summary displays the final energy values for each subsystems. This is the important thing. This also it includes the electric plant summary. It shows the average efficiency, and drivetrain plant summary indicates average efficiency. Also the important one, this one, data inspector block. This data inspector box used, that is also called as simulation data inspector block. Here itself we can compare the data, inspect and compare the data and the simulation results to validate and iterate. You can iterate this model designs using this STA plot, that is a simulation data inspector plot. We can inspect and compare time series data at multiple stages and your user workflow. Here how to get this Simulink data inspector block means in Matlab command window you will type simulink.sda.view. After this one, otherwise we can use this Simulink tool strip. In the Simulink tool strip, in tool strip icons, you can click here in this model. This is a data inspector. On the simulation tab under the review result, you can click data inspector review results. Click data inspector, you will get. Now we are going to see this model. What is the we can analyze or measure fuel economy and emissions, and this is a power and energy blocks. Now we can run this model. You can choose variable types of simulation, that is a normal mode or acceleration mode or rapid acceleration mode. Here you can use a normal mode or based on your requirement you can choose to run this block. Then after clicking this one, our analyze power and energy block, you will get this online live script. Now you can run this model here. It takes some more time to run. In this block, before you run this model, before you get this model, you type in this command window, you type auto block EV start command. That is nothing but your auto block power auto block EV start application. Then only will get. Then now we are getting this model, that is auto block EV start model. Now it opens the project like this model. According to your drive cycle source, it shows the output, that is a visualization output. It shows the trace velocity and the target and the motor speed and motor torque and battery state of charge and battery current and US economy, fuel economy. Here you can see. It shows one cursor measurement option. Here itself there are two more cursors are available here. Now we can see here itself you can identify this block, and during simulation time also you can compare the US fuel economy and motor torque. Here here itself you can see this model, the cursor model. Based on this cursor model you can see here it's better battery state of charge diagram. After finishing this simulation, you will get this energy report. Here itself you can change the waveform cursors for trace velocity or target actual part 1 and part 2, and also you can analyze the waveform for motor speed, motor torque, and this one motor battery state of charge. Also now the simulation part is over. Now we can see the data inspector block, and also we can verify. Here these were analyze the performance analysis block. Here dependency analysis we are going to see. After simulation you will get this project EV block. Here itself these were EV reference application block. Based on that, here these are all the models are developed by using this Matlab live script. Here this is a powertrain controller block, that is a battery EV, and this is a motor generator dynamic block and Matlab block and drivetrain blocks. After that you will get the energy report, and this is where powertrain controller block, and also you can generate Matlab script file, and also Matlab live script file also we can use. Here this is a dependency analysis block. Also you can see impact V on table V here. Also you can save this file, analyze all, and this is a project EV project here seeing now. Now run this simulation. Now after the running this block, we will get this live script file to generate energy report, power and energy report. Here there are it shows overall summary block. These were run simulation overall summary block and electric plant summary block and the drivetrain plant summary block. And finally it shows the SDA plots, that is a Simulink data inspector block, that is SDA plots to view result in electric plant and drivetrain plants. Here on this overall summary it is displayed. Now it is coming here the performance and FE scope for this particular drive cycle, and also you can make you can here itself you can change this one, this drive cycle source block, then only then we can get according to this drive cycles you will get this visualization like this. Now it's a live script is running on. After finished you can also import Also you can save in the form of a PDF report as report in the form of PDF file or a word file or HTML file or latex file. Also you can save this file as Matlab project, that is a EV projects. You can see. Now we are going to see about this data inspector block before it completes. Here what are the blocks are included here after creating this model. Here these are all the models are there to analyze the performance chart. Here you can see I am using this. If you are selecting this table, there are 4 tables are available here to compare this one. For example, I am using this fuel economy and the battery state of charge. Based on that and live report it will come. It's a US fuel economy and where battery state of charge. And I want to see what is the motor speed and motor torque for this one. It also it refers, that is blue line indicates this motor torque, and this one motor speed and RPM it shows. And I want to check the trace velocity versus your battery current, and also it also possible based on that one. And I want to check this lithium battery pack. I want to check this battery analysis for power accounting, bugs creators, and these are mapped data. This one also you can use for battery state of charge, and with this one lithium ion battery charge. You can see these are state of charge is available at this point. You can also compare this result. Also you can export import and export. Also based on that value, based on that comparison, you can generate a report also. This is an important feature of this one. You can also generate report. In report format is available, file name in form of HTML file. You can create the report. Now access is done because the live script is going on now. Like live script is running. Now this overall summary part is going on. It takes some more time because this is an electrical project. It also doing this independency analysis for powertrain control algorithms. Also you can incorporate that's regenerative. Previously we discussed regenerative block and some different kind of diagnostic algorithms, especially for control and diagnostic algorithm system design. And also it is useful for this HAL testing. It also associated with inbuilt powertrain control algorithms. Also it has the direct drive transmissions. Also it has some battery management algorithms, so that it needs some more time to get this result. Also you can check this performance according to the drive cycles. You can see in the right hand side first and second scope. Here itself also you can measure this motor speed and target current. Also one more thing is that you can also use this legend model. It shows the legends address. What is the yellow line indicates what is the blue line indicates the trace velocity and motor torque and speed, battery current in amps, US fuel economy. Based on that you can measure. And also you can use this measurement and signal statistics also you can use. Based on the trace you will get the maximum value and minimum value, peak to peak values, and median value, RMS value. Based on that you can measure. And this by level measurements block also there. Based on that you can set this transition state level tolerance and upper reference level. All the differentiation is possible under this performance and fuel economy scope here. And this block also allows to get this STA plot. Now this electrical plant summary process is going on. You have to wait for some time to get this report average efficiency report for both electric power plant summary and the drivetrain plant summary. Based on that you can get by using this scope is a cursor measurement and the signal statistics and bi-level measurements. And also one more application by using this performance FE scope. To get this help, the EV reference applications in Matlab example files, there is a particularly it is available in Powertrain block set. If you are Matlab user, you have to get this to install add-on package to get this drive cycle source. Then only your previous one for normally the default drive cycle source is FTP 75 default source is available. This it has 2474 seconds it's set the drive cycle source. Now we are getting this overall summary. This one, the overall summary displays the final energy value of each subsystems. It shows the reference systems, system name and efficiency and the energy losses and the energy input. Why are getting this error occur means we are at the time of simulation we are changing these drive cycles, and also we are performing some more. Now after finishing this simulation, this drive cycle source simulation, you will get exact energy report. Based on that, we can practice well. You can see there is a lithium ion package here. Unable to save the workbook file here. I have this sufficient disk space. I have not so that we are getting this error. Finally, for example, we are getting this output based on the previous drive cycle. Now simulation also parallel running, so that the error is occurred. Also you can test this model with different types of electrical drive source. You will get better result. Now we can see the only 30% 31% simulation is going on. Also you can choose accelerator mode. You will get more result for looking for SIL and PL simulation. You are using this tab for you are setting the stop time. Also you can use. Now you can see with the different model, different drive cycles. So battery current source. It's an online script or you can get. Also you can save this file in the form of PDF. This one is around untitled block you are getting. Each and every block you can see. This is a EV reference application block. This is average efficiency, energy input, and electrical plant, and what is a battery block. The same thing you can see here itself. You can also change the parameters value. Based on that, you will get output. These are control systems and power and analyze block. Now simulation is going on. The one thing important to get this model, to get this example, or to create an open working copy of the conventional vehicle reference application project here in this model. That is where Matlab command window you have to type the command, that is auto block EV start. Then only you will get this block, that is a EV reference applications, that is a electric vehicle project block. Then only will get this energy model, that is where EV reference application model to analyze power and energy block. If there is any difficulty you are facing, kindly ask in YouTube chat box, not in my mail, so that I can easily see your questions and we can analyze. Here in this manner you can see. Also you can make this figure into print figure option. Also you can use different types of measurements, that is a trace cursor measurement, signal statistics, and peak finder block. Also it is possible here. By using this waveform cursors, you can differentiate your trace velocity block or motor speed block and motor control block and battery system state of charge, and also this block called here Simulink data inspector block. This is Simulink data inspector block. Also you can compare the result by using this motor battery or any value you can compare here. By, this is an important feature of this Simulink data inspector block. Also, you can save your files in the form of live editor or live Matlab files. Okay, here you can make it as different types of electrical vehicle source. Here you can see at the time of simulation finished, you can try to replace any other cycle. That is where also you can measure with your own data, plot data. Here this is your urban driving cycles. It's a low powered vehicles. If it is your low powered vehicles, it is an alternative for low powered vehicles for part 2. You see type 1, type velocity 2, velocity UN. It is a shows us UN EC extra. That is a urban driving cycle, low powered vehicles. Based on that, you can analyze power and fuel economy and emissions. You can easily analyze by using this application project. Thank you.